Your 1-5 lesson goes over different transformations for parent functions. Your parent functions are like what you see here, like that f of x is equal to x. Same thing with something like f of x is equal to x squared. F of x is equal to x cubed. F of x is equal to the square root of x. And f of x is equal to the absolute value of x. So those will be the 5 parent functions that we work with this section. You're going to use those in order to state different transformations from given function rules. You're also going to use those parent functions when you give the function rule when you're given different transformations. The first transformation that we're going to look at is your vertical and horizontal shifts. So these happen going up or down. So this will be something like h of x is equal to x squared plus 2, like you see here. It'll also be something like h of x is equal to x squared minus 2. These plus 2 minus 2's that you're looking at will be after your parent function. So it'll be after the x squared, it'll be after the x cubed, after the absolute value of x, after the square root of x. If it's plus a number, that means that it's going up that many units. If it's minus a number, that means it's going down that many units. Okay, so again, these are after the parent function. So if you have the x squared plus a number, it means that it's going up that many units. If it's x squared minus a number, you're going down that many units. The other type of shift is your vertical and your horizontal shifts. So these are to the right and to the left. Now these are a little bit more difficult because they're inside the parentheses with x, or underneath the radical with x, or inside the absolute value with x, and they are opposite of the sign that's in front of them. So you normally think plus a number, you're going to the right on a number line. Well, in this case, it's going to be opposite of that. So you'd go to the left that many units if it was plus a number inside with x. If it's minus a number, you're going to the right that many units. So this g of x is equal to x minus 2 squared. That minus 2 means you're going to the right 2 units. It's going to be opposite of what you think looking at a number line. Okay, so like we said, I'm looking at the top right-hand corner here. G of x is equal to x plus a number squared. You're going to the left that many units, because again, opposite of what the sign is in front of the number inside the parentheses. And then g of x is equal to x minus the number squared. It means you're going to the right that many units. Okay, so we have 2 graphs here. The first on the left, you have a vertical shift up 2 units. So that one would be your x squared plus 2. Like you see there. The one on the right, you're going to the right 2 units. So again, we put that in parentheses, bless you.
Oh, thank you.
In parentheses, opposite, so it's minus 2 inside. If we look at some examples, it just tells us to state the transformations. For example A, we have g of x is equal to x squared minus 4. For this one, we have that minus 4 after the x squared, no parentheses, so we're going down 4 units. For b of x, we have g of x is equal to x plus 3 squared. That plus 3 is on the inside of the parentheses, so we want to think opposite. We're going to the left 3 units for this one. For example C, you have h of x is equal to x squared plus 9. It's another one that's not in parentheses with the x, so that plus 9 means we're going up 9 units. For example D, we have h of x is equal to parentheses x minus 7, close parentheses squared. That minus 7 is inside the parentheses with x, so we're going to the right 7 units. For example, E, you're given g of x is equal to x minus 2 squared plus 5. This one you have two different transformations. So when we work with more than one transformation, we work with the function from left to right. So just like we do by looking at graphs and working with their slopes, we look at the line from left to right, you do the same exact thing with this. So your first function that you see there is the one that's in the parentheses, which is that minus 2. It's in the parentheses, so think opposite of negative 2. That would be positive 2, so we're going to the right 2 units. Next, we have that plus 5. That's after the parentheses and after the squared. So that one's outside. That means that's happening vertically. We're going up 5 units. For example, F, we have h of x is equal to x plus 4 squared minus 3. Again, we're going to work left to right here. We have that plus 4 inside the parentheses, so think opposite. We're going to the left 4 units. And then after the parentheses and the squared, we have that minus 3, so that means we're going down 3 units. Your table here just shows you the different transformations that we've gone through so far. So again, if it's plus a number outside or after the parent function, it's up that many units. If it's minus a number, it's going to be down that many units. If it's inside the parentheses or inside the radical, inside the absolute value with x, and it's minus a number, we're going to the right that many units. If it's plus a number inside, we're going to the left that many units. Your next example, you are given the parent function and you are writing the function rule. For example, A, it tells us to use the parent function f of x is equal to x cubed to write the function rule with a transformation of 1 unit upward. So we're going to start with the x cubed. We have 1 unit up, so that means that it would go plus 1 after the parent function, which is the x cubed. This is not going to be named the same as the parent function, which is f of x, so we're going to rename it as g of x. Again, it just has to be something that's different than the f of x. For example, B, it tells you to use the parent function of f of x is equal to x cubed. So again, we're starting with the x cubed. To write the function rule for the transformation 1 unit to the right. 1 unit to the right means that we're in parentheses with x, and we're going to be minus instead of plus. It's because we're thinking opposite. So this 3 is going to have to be moved, and you're going to have to put parentheses around that x to where you have x minus 1 cubed. And this is going to have to be named something different than f of x, so we'll name it g of x. So you have g of x is equal to x minus 1 cubed. For example, C, you're told to use the parent function of f of x is equal to x cubed. So we're going to start with x cubed again. To write the function rule of the transformations of 2 units to the left. So that's going to be in parentheses, so plus 2. And then 1 unit down, so that's going to be minus 1 after the x, not in parentheses. So first thing we're going to do is move the cubed, put parentheses around the x, and put the plus 2 to represent the shift 2 units to the left. That cubed would have to go after the parentheses. And lastly, we put the minus 1, and we name this g of x. So we have g of x is equal to x plus 2 cubed minus 1. The next transformation that we're going to look at is your reflections. You have reflections across your x-axis, and you have reflections across your y-axis. If you think about your x-axis and you are reflecting across your x-axis, that is happening vertically. So that means that your reflection is going to be represented vertically, so there would be a negative in front of the x. If you had a reflection over your y-axis, that's happening horizontally. If it happens horizontally, that means that it's happening side to side, and any transformation that happens side to side or horizontally is inside those parentheses under the radical or inside the absolute value. So that means you would have something like g of x is equal to parentheses negative x squared. Okay, so vertically happens outside, in front, horizontally happens inside, in front of the x. Okay, so if you're reflecting across the x-axis, it's going to be the negative x squared, that's in orange. And then if you're reflecting across the y-axis, it's going to be parentheses negative x, close parentheses squared, like in the pink. Same thing, but that this tells you, okay? A reflection across the x-axis, you got h of x is equal to the opposite of f of x, which is the same thing as h of x is equal to the opposite of x. And then the reflection across the y-axis, you have h of x is equal to f of negative x, which is the same thing as h of x is equal to parentheses negative x. Your last example that we're going to look at today, you have these two graphs, and you're going to state the transformations and write the function rule for each of the functions. For example A, you have this function y is equal to g of x, so we're going to name this function g of x. So that's what we're naming this. This function, we said, or we're told, that it's the parent function of x squared. So that x squared is what's having things done to it. X squared is the function that looks like this. So it's a u that's facing upward. With example A, that u faces down, so we are reflecting across the x-axis. Other than that reflection across the x-axis, instead of it being at your origin, it moves 2 places up, so we're also going up 2 units. So we are all working vertical here. So that negative for your reflection across the x-axis is going to go in front of the x squared, and then the up 2 units is going to go after the x squared as plus 2. So you have the function g of x is equal to the opposite of x squared plus 2 for your function rule for this graph. For example B, you have this function that is facing downward, so we have a reflection across your x-axis again. But this time we are moving from your origin to the right 1, 2, 3 units. So this also tells us that this one's being named h of x. So we're going to have the parent function of f of x is equal to x squared, so our new function is going to be h of x is equal to x squared. Something's going to happen to that x squared. You're reflecting across the x-axis, so your negative goes in front of the x squared. You also are moving 3 units to the right, so that's inside the parentheses with x. So we're going to put parentheses after the negative. We're going to move the power and put the minus 3 to represent to the right 3 in with the x and keep it squared. So we have h of x is equal to the opposite of x minus 3 squared. If we continue with these notes, the next type of transformation that we're going to work with is your vertical stretch and your vertical shrink. Your vertical stretch and your vertical shrink actually has to do with the graph, like the way that the line is drawn. So for example, if you were working with a function that looks like a V, so like just like this one up here, if it was stretching vertically, it would stretch vertically this way. So the distance between the two sides would practically be the same, but it would stretch upward. If it was shrinking, it would stretch downward, so it would kind of widen a little bit, but still keep that distance kind of in between, but just like I said, be shrunken. Your vertical stretches and compressions have to do with the number that's in front of x. So if you look here with your left side with your vertical stretch and your vertical shrink, the number that's in front of the x is going to tell you whether or not it's a stretch or a compression or a stretch or a shrink. If it's a stretch, it's going to be a number greater than 1. If it's a shrink, vertically, it's going to be a number between 0 and 1. So most likely a fraction that's less than 1. So those are the numbers that are in front of x, in front of the parentheses, or no parentheses are there. If you have a number that's in front of x inside the parentheses, that's going to be either a horizontal stretch or a horizontal shrink. Again, that's inside the parentheses, so it's horizontal. With those, you want to take the reciprocal of the number. So you're first going to take the reciprocal, and that reciprocal is going to tell you if it's a stretch or a compression. If the reciprocal of the number in front of x in the parentheses is greater than 1, you have a horizontal stretch. If the reciprocal of the number in front of x inside the parentheses is less than 1 but greater than 0, so it's going to be a horizontal shrink. So you have to pay attention about where the number is in front of x, whether it's just in front with no parentheses, that'll be a vertical stretch or compression, or in front of x inside the parentheses. If it's in front of x inside the parentheses, take the reciprocal of that number and then go from there. If we look at our example 5, it tells you to state the transformations. For A, we're given g of x is equal to 1/3 times the absolute value of x. That 1/3 is in front of the absolute value, so we don't need to do anything with it. The 1/3 is less than 1, so that means we have a vertical shrink by a factor of 1/3. For example, B, we have h of x is equal to parentheses 2x, close parentheses, squared. That 2, you're going to take the reciprocal of it, so it's going to become 1/2. That 1/2 is less than 1, so because it's on the inside, it's horizontal. Because it's less than 1, it's a shrink. And the factor is 1/2. So that's a horizontal shrink by a factor of 1/2 for that one. For example, C, we have g of x is equal to 5/3 x squared. That 5/3 is in front of x. There is no parentheses, there's no absolute value, there's no radical. So it's just going to be vertical. That 5/3 is greater than 1, so that means that it's a stretch by a factor of 5/3. Then for example D, you have h of x is equal to 1/7 times x to the power of 3. That 1/7 is inside the parentheses in front of x, so we're going to flip that fraction. It becomes 7. The 7 is what you are comparing to 1. It is greater than 1, so we have a horizontal stretch by a factor of 7. So with these horizontal stretches or horizontal shrinks, your factor is actually the reciprocal of the number that's in front of x in the parentheses. For your next set of examples, you can use the top part of here. This g of x is equal to the opposite of a times the opposite of b times x plus c squared plus d to recognize your different transformations. You are going to be stating the transformations for each of the following function rules. You need to work with these from left to right, okay? So use this as a guide when you're going to answer these questions. For example, A, you're given g of x is equal to the opposite of 1/3 times 2x plus 7 squared minus 4. The x and the squared don't matter. What matters is what you start with at the beginning, which is that negative. That negative is reflecting vertically, so we have a reflection across the x-axis. Next, we have that 1/3 that's in front of the parentheses. That 1/3 tells us that we have a vertical vertical shrink because it's less than 1 by a factor of 1/3. Next, we have that 2 that's inside the parentheses in front of x. So we're going to take the reciprocal of that. That becomes 1/2. That 1/2 is less than 1, so we have a horizontal shrink by a factor of 1/2. Next, we have the +7, which becomes -7 or -7, so we're going to the left 7 units. And lastly, we have that -4, meaning we go down 4 units. So with these examples, you are taking all of your transformations and plugging them into the same problem and stating every single one of them. For example B, we're given h of x is equal to 9 times the opposite of 4/7 x minus 3 cubed plus 2. You're starting with the 9 on this one. That 9 is in front of the parentheses, and it's greater than 1, so we have a vertical stretch by a factor of 9. Next, we have the negative that's inside the parentheses, so we have a reflection horizontally. So that means that this reflects over the y-axis. Then we look at the 4/7. It becomes 7/4 since we take the reciprocal of that number. That 7/4 is greater than 1, so we have a horizontal stretch by a factor of 7/4. Next, we're moving to that -3, so think opposite. That would be +3, so we're going to the right 3 units. And lastly, the +2 means that we're going up 2 units. For example C, we have j of x is equal to -4 times the square root of -2x plus 1 minus 5. Start with your negative that's in front of the 4. That reflects vertically, so that's going to be across your x-axis. Next, you have that 4, which is in front of the square root. So keep it as it is. Compare it with 1. It's greater than 1, so that's a vertical stretch by a factor of 4. Move into your radical now. That negative that's in front of the 2 reflects horizontally. So we're reflecting across your y-axis. Next, that 2 we take the reciprocal of, so it becomes 1/2. That 1/2 is less than 1, so that's a horizontal shrink by a factor of 1/2. Then we have the +1 underneath the radical, so think opposite. We're going to the left 1 unit. And lastly, we have that -5, which means we're going down 5 units. For your last set of examples, you are writing the function rule given the transformations. With these, it does not give you a parent function, so we are going to use the parent function f of x is equal to the absolute value of x. Okay, so we're going to start with the absolute value of x for both of these. For your first one, example A, it tells you that you have a vertical stretch by a factor of 8/5, a reflection over your y-axis, a horizontal shift right 6 units, and a vertical shift down 2 units. Well, to start this off, we're going to have to name it something other than f of x, so let's name it g of x. It has a vertical stretch by a factor of 8/5. That's vertical, so it's going to go in front of your absolute value. So that 8/5 goes in front, not 8/3, 8/5. From there, so I'm going to dash each of these. From there, we are reflecting over the y-axis. If we're reflecting over the y-axis, that's happening horizontally, so it's going to go in front of the x inside the absolute value bars. So we're going to have to move this, put the negative in front of the x inside the absolute value bars. Next, we have a horizontal shift right 6 units. It's inside because it's horizontal. So then we're going to the right, so that means that we're going to turn this into x, negative x minus 6. So we're going to get rid of that real quick, put the minus 6 down, and then reclose the absolute value. From there, lastly, you have a vertical shift down 2 units. So that means that we're going down 2 units. We'll subtract 2 from this. So we have g of x is equal to 8/5 times the absolute value of negative x minus 6 minus 2. For our last example, we have a reflection over the x-axis. Then we are vertically shrinking by a factor of 0.8. Then we are reflecting over the y-axis. We have a horizontal stretch of a factor of 7 and a horizontal shift of left 7 units. So we're starting with the parent function of f of x is equal to the absolute value of x. If we are reflecting over the x-axis, that negative is going to go in front of the absolute value bars. From there, we are vertically shrinking. If we're vertically shrinking, whatever our factor is stays what it is, and that factor goes in front of the absolute value bars. So our factor is 0.8. That means we are going to move this negative to be in front of the 0.8. So now we have the opposite of 0.8 times the absolute value of x. Next, we are reflecting over the y-axis. So that negative is going to go in front of the x inside the absolute value. So we're going to move that. So that's going to turn into the opposite of x. Next, we are horizontally stretching by a factor of 7. So since it's horizontal and we're stretching, we're taking the reciprocal of this to be 1/7, and that 1/7 is going to be in front of the x. So it's going to go after the negative, but in front of the x inside the absolute value. So we're going to have the opposite of 1/7 times x inside. Lastly, we are horizontally shifting to the left 9 units. So if we're going to the left 9 units, that means we're just going plus 9 inside those absolute value bars. So if we name this, let's name it g or h of x because we named the other one g of x. We're going to have h of x is equal to the opposite of 0.8 times the opposite of 1/7 x plus 9 inside the absolute value.